Hello everyone. In this class we shall do another problem on Gram-Schmidt process of orthogonalization. In our previous class we have already familiar with this process and also we have done a problem on this treatise. Today we are considering another problem on Gram-Schmidt process of orthogonalization. Here we have considered the Euclidean space R4. Euclidean space R4, and conventionally the inner product defined on this Euclidean space is the standard inner product. In this problem you have to make or you have to construct an orthonormal basis for the vector space which is generated by these three vectors. 1, 1, 0, 1, 1, 0, 1, 1, -2, 0, 0, 1, 0, -1, 2. So let us now start. Here we have renamed this vector. We are considering this alpha 1 vector. This is equal to this vector 1, 1, 0, 1. We are considering the alpha 2 vector as the second vector of the basis set 1, -2, 0, 0, and also this third vector 1, 0, -1, 2. We are considering this vector as this alpha 3 vector. Okay. Again, similarly as our previous problem which we have done in our previous class, we are renaming this alpha 1 vector as beta 1. That means beta 1 equal to alpha 1, and we are constructing another vector beta 2 in such form: alpha 2 minus c1 into beta 1, alpha 2 minus c1 into beta 1. Alpha 2 is this second vector of this collection. Okay, and of course c1 is the scalar component of the vector alpha 2 along the vector beta 1. And how to calculate this scalar component? Everybody are familiar with this. So c1 equal to c1 being the scalar component of this alpha 2 vector along the vector beta 1, we are writing c1 equal to the inner product of alpha 2 beta 1 divided by inner product of beta 1 beta 1. That means alpha 2 beta 1 divided by beta 1 beta 1. And as I have told you that conventionally we are considering the standard inner product on this Euclidean space R4. Okay, so the alpha 2 vector is this -1, -2, 0, 0, and the beta 1 vector is this first one, the alpha 1 vector 1, 1, 0, 1. Okay, so alpha 2, beta 1, that means the inner product of alpha 2 beta 1. The inner product being the standard inner product, this would be equal to the first component is 1 for the vector alpha 2, and for the vector alpha 1 the first component is 1. So this first one will be 1 into 1 plus the second component is -2, and the second component of alpha 2 vector is -2, and the second component of this alpha 1 vector is 1. So this plus 1 into -2. The third component of this alpha 2 vector is 0, and the third component of alpha 1 vector is also equal to 0. So the third member, this is a plus 0, and the third component of this alpha 2 vector is 0, and third component of this alpha 1 vector is 1. So plus 1 into 0. And the inner product of beta 1, beta 1 vector is this 1, 1, 0, 1. So the inner product of beta 1 is 1 square plus 1 square plus 0 square plus 1 square. So we have written 0, 1 square plus 1 square plus 0 square plus 1 square. And after calculation we have the value of this C1 equal to minus 1 by 3. And now we are substituting the value of C1 in this equation, beta 2 equal to alpha 2 minus C1 beta 1. So beta 2 equal to alpha 2. The alpha 2 vector is this 1 comma minus 2 comma 0 comma 0. So in place of alpha 2 we have written 1 comma minus 2 comma 0 comma 0 minus C1 we have substituted the C1 by its numerical value, that means minus 1 by 3 into beta 1 vector. Beta 1 is the alpha 1 vector. So alpha 1 being 1 comma 1 comma 0 comma 1, we have written here that very 1 comma 1 comma 0 comma 1. And after simplification we have the beta 2 vector is as 4 by 3 comma minus 5 by 3 comma 0 comma 1 by 3. Beta 2 we have constructed in such a way. Okay. And beta 2 we have constructed considering this alpha 2 vector, alpha 2 minus C1 beta 1. Okay. And in this collection one vector alpha 3 is remained. So next we have to construct another vector. We shall have to construct another vector considering this alpha 3 vector, and we are constructing that vector and renaming that vector as beta 3. Beta 3 equal to, we have considered this alpha 3 vector, so alpha 3 minus the remaining another two vector. One vector we have constructed and one vector we have assumed as the alpha 1 vector. That means we have renamed the alpha 1 vector as beta 1. We are writing this. So beta 3 vector equal to alpha 3 minus d1 into beta 1 vector minus d2 into beta 2 vector. And of course this d1 and d2 would be the scalar components of this alpha 3 vector along beta 1 and beta 2 respectively. That means d1 is the scalar component of this alpha 3 vector along the vector beta 1, and d2 is the scalar component of this alpha 3 vector along the vector beta 2.